If you're ready, you may start.
Okay, good morning everyone. So our report for today is about types of chemical reactions, the experiment 3. For our introduction, although countless chemical reactions exist, nearly all of them can be classified into a few specific categories. In this experiment, you will learn to differentiate 5 general types of chemical reactions. Some of the reaction you will perform, others will be demonstrated by our teacher. From observations, you'll identify the products of each reaction and determine the type of reaction that has taken place. You will consider the following reaction types: combination reactions, decomposition reactions, single replacement reactions, double replacement reactions, and combustion reactions. The majority of common chemical reactions can be classified as belonging to one of these categories. There are 2 types of double replacement reactions that will be investigated: the precipitation reactions and gas-forming reactions. In this experiment, these 6 types of reaction will be performed. The evidence that reactions are occurring may be a gas produced, a precipitate, a color change is observed, and a temperature change is noted, and a flame is produced. The purpose of this lab is to give the learner hands-on experience in classification, observation, and analysis of various types of chemical reactions. Henry, nasa mute po si Henry.
Yeah, dito siya.
Sandali lang po ma'am, nagka-problem po, nakadita lang po kasi halos sa amin kasi brownout po.
Okay.
So using the diagram, here is the procedure for the single replacement reaction. So first, obtain a clean well plate. Second, place a small piece of zinc metal in one well. Record your observations. Third, fill the well about 2/3 full of copper 2 sulfate solution. And lastly, observe the zinc and solution. Return to the station later to observe any changes and record your observations.
In the combination reactions, first we obtain a small piece of magnesium ribbon, then record your observation of the metal. Light and adjust the Bunsen burner to a hot blue flame. Next is using tongs, hold one end of the magnesium in the hot outer cone of the flame. Once the magnesium ribbon has ignited, hold it over your lab station. Lastly, we observe the properties of the product and record your observations.
Who's next?
Next is the combination reaction. Place a tiny lump of calcium oxide about the size of a match head in a clean well of the well plate. Observe the record, then record your observations. Next is fill the well about 2/3 full with distilled water. The next step is use the steering rod to mix the calcium oxide and water. Then record your observations. Next step is place 1/2 strip of red and 1/2 strip of blue litmus paper on your lab station. And lastly, using the steering rod, place a drop of the solution from the well on each litmus strip, then record your observations.
The composition reactions. Place a small crystal of copper sulfate pentahydrate in a small dry test tube. Record your observation. Next is hold the test tube over the lab station with the mouth of the test tube tilted slightly downwards. Evenly heat the bottom portion of the test tube with a hot flame. Record your observation of the materials being given off for the test tube. Next is allow the test tube to cool in a rack. You may want to complete other stations and then return later. Lastly, allow the test tube to cool in a rack. Ay, same lang po pala yun, na double po. Place a few drops of potassium iodide solution in a clean well. Add a few drops of lead nitrate. Record your observation. Repeat step 1, but instead use silver nitrate solution and sodium chloride. Caution: silver nitrate solution can stain skin and clothing.
Precipitation reaction. First, place about 2 ml of lead 2 nitrate solution into a clean medium test tube and place about 2 ml of aluminum nitrate solution into a second clean medium test tube. Next, add about 2 ml of potassium iodide solution to both of the test tubes. Record any evidence of chemical change in your data table. Lastly, if a precipitate forms, write the balance equations in the reaction table. If no reaction occurred, write NR. Place both solutions in a waste beaker on your lab bench.
precipitation reactions. Place about 2 ml of copper 2 sulfate solution into a clean medium test tube and place a medium test tube. Add about 2 ml of sodium phosphate solution to both. Record any evidence of chemical change in your data table. If a precipitate forms, write the balance equation in the reaction table. If no reaction occurred, write NR. Place both solutions in a waste beaker on your lab. Gas forming reactions. Place about 3.0 ml of sodium bicarbonate solution in the bottom of a large test tube. Add a few drops of 6 molar of hydrogen chloride solution. Record any evidence of chemical change in the observation data table.
Combustion reaction. First, place a candle upright on the center of a foil-covered watch glass. Next, carefully lower a beaker over the lighted candle. Observe and record until no more changes are evident. Lastly, light a splint. Carefully lift one edge of the beaker and insert the lighted end into the beaker next to the candle. Record your observations.
So for the data table, for the experiment A, the given reactants are Zn, zinc plus CuSO4, stands for copper 2 sulfate. The products are ZnSO4 or zinc sulfate plus Cu copper. So the type of reaction for the experiment A is single replacement. Why single replacement? Because more reactive element replace less reactive element.
On our B procedure, we have our reactants, which are the magnesium and the oxygen. Then we will have a product of magnesium oxide. Then this type of reaction is a combination reaction. Since we combine the magnesium element and the oxygen.
Who's next?
Letter C, our reactants is CuSO4 and H2O. For our products, we have CuSO4 plus 5H2O. It's already balanced. So our type of reaction is decomposition reaction. For letter D, we have potassium iodide plus, our reactants is potassium iodide plus PbNO3. For our products, we have KNO3 plus PbI. For type of reaction, we have double replacement reaction.
For precipitation reactions, we have two sets, set A and B. For set A, our reactants, 2 ml of lead 2 nitrate was added with 2 ml potassium iodide solution. So remember the solubility rules. All halides are soluble except for silver, mercury, and lead. Since lead is present, so it then yields to a yellow precipitate known as the lead iodide, and an aqueous solution, which is the potassium nitrate. Next is 2 ml of aluminum nitrate was added with 2 ml of potassium iodide solution. Since nitrates are soluble compounds, therefore the reactants does not form any precipitate, meaning there is no reaction, so NR. For the second set, 2 ml of copper sulfate was added with 2 ml of sodium phosphate solution. Sulfates are soluble, but phosphates are considered insoluble. Therefore, the reactants yields to a blue precipitate known as the copper 2 phosphate and sodium sulfate as the aqueous solution. And next, 2 ml of aluminum nitrate was added with sodium phosphate, and phosphate here is insoluble, therefore a reaction occurred. A white precipitate is formed, which is the aluminum phosphate, and an aqueous solution also, which is the sodium nitrate. So for the type of reaction, we have the double replacement.
For gas-forming reaction, our reactants is sodium bicarbonate plus hydrogen chloride. Our products would be sodium chloride plus carbonic acid. But with carbonic acid, we can further decompose carbonic acid into water and H2O. So our final product would be sodium chloride plus water plus CO2. So we have two types of reaction, and that is double displacement and decomposition reaction.
And for the experiment A, we have the reactants. For the reactants, we have CuCO3 for copper carbonate. And for the products, we have CuO, which is copper oxide, plus CO2 carbon dioxide. And the type of reaction for the experiment E is combustion.
For the guide questions, question number 1, what evidence do you have that the color of copper 2 sulfate pentahydrate is related to the presence of water in the crystal? The presence of water H2O in the crystals determines the color appearance of the copper 2 sulfate sample. If copper 2 sulfate pentahydrate appears to be blue crystalline granules, it correlates that water is present in the sample. On the other hand, if the color is white, then the water has evaporated or is absent. Therefore, the color of copper 2 sulfate pentahydrate determines the presence or absence of water in the sample.
Number 2, would you predict that the ash formed when magnesium burned would have a greater or lesser mass than the original piece of magnesium metal? Why? I think it would or should be greater rather than the original one because the amount of magnesium stays the same. Number 3, what evidence do you have that the product of calcium oxide and water is basic rather than neutral or acidic? Litmus test can provide an evidence that the product of calcium oxide and water is basic rather than neutral or acidic. When the solution turned the red litmus paper to blue, or the blue litmus paper remains blue, it indicates a high pH level, and that makes a solution, or that shows that the solution is basic.
Conclusion. All in all, there are different types of reaction we have encountered, which are the combination reaction, decomposition reaction, single replacement reaction, double displacement reaction, and combustion reaction. And I've learned that these types of reaction can help us identify a compound, elements, and other properties of chemicals.
That's all po, ma'am.
Okay. Have you prepared videos of the procedure? Sorry ha, nag-off ko cam kaya nag-conserve ko sa kong data sa ako ang laptop. Do we have videos?
Yes po, pero dalawa lang po yun, ma'am. Hanapin ko po muna. Kasi di po kasi ako dapat yung mag-screen share. Kaso lang po, brown out po kasi sa mga kasama ko.
Okay. Sige.
Hanapin ko po muna yung na-download ko, ma'am.
Okay.